GATE 2018 Civil Engineering Set 2 Question 28. The rank of the following matrix is 1 1 0 minus 2 2 0 2 2 and 4 1 3 1 in rows are given. Four options given are 1 2 3 and 4. The relevant NPTEL reference has been cited. When it comes to finding the rank of a matrix, so we will be given a matrix with certain rows. The first thing that we need to do to find the rank is convert it into row echelon form. To do this, we take the last row, that is the nth row of the matrix, and we do some kind of transformation that may be a combination of this row and some other row. Using this transformation, the element on the left side for the last row is made 0 and other rows are left intact. Similarly, this process is repeated for the second last row and two zeros are made and the rest of the rows are left intact. After repeating this process, in the end we will have rows with entirely 0 and certain number of rows which may be left with certain elements. So the number of non-zero rows that are left is called the rank of the matrix, and this form where a certain number of rows in the bottom of the matrix are 0 and some of the rows at the top may be non-zero is called the row echelon form for the matrix. So in order to find the rank of a matrix, first it should be converted into the row echelon form, and then the number of non-zero rows in that matrix is given as the rank. The matrix that has been given in the question is, let us call it A, which is 1 1 0 minus 2 2 0 2 2 and 4 1 3 and 1. So the first thing that we need to do is we should make this element 4 as 0 using elementary transformation. So if we subtract R3 from 4 times R1, we can see that this element would become 0. So using R3 tends to R3 minus 4R1, this would give the value as the first row will be left intact, second row will be left as it is, and this element would become 0 and the rest of the elements would become minus 3, 3 and 9. Now what we need to do is we should make this element, this 2, as 0. So we can see that if we subtract the second row from 2 times the first row, that is R2 tends to R2 minus 2R1. So if we do this, this 2 would become 0. So we have not done any operation on the first row, that will be left as it is. This element would become 0, it would become minus 2, 2 and 6, and the third row will be left intact, minus 3, 3 and 9. Now we can see that the second row is a multiple of 2's and the third row is a multiple of 3's. So using the LCM concept, both these rows can be operated together to convert the entire last row together to 0. So using the operation R3, if we multiply R3 with 2 and then subtract 3 times of R2, the last row would become 0. So the first row has been left intact, second row is left as it is, and the last row would become 0 after this operation. It can be seen that no matter what kind of operations are applied now, the first 2 rows cannot be made 0. This ensures that the non-zero rows in the matrix A are equal to 2. The last row became 0 and the rest of the 2 rows R1 and R2 are non-zero. This ensures that the rank for the matrix A is equal to 2. So the rank of the following matrix is 2, which is option B. The relevant NPTEL reference has been cited.